Good morning, students. Welcome back to chemistry class. Today we are going to study about uses of hydrogen in first volume, fourth chapter, page number 105. Okay, uses of hydrogen and the introduction about the water molecule. Compounds of hydrogen, about the introduction of water. Today we are going to discuss. Okay, first upon uses of hydrogen. Uses of hydrogen. Hydrogen is used for many purpose. Okay, there are seven uses given in your textbook, but more and more applications are having for the hydrogen. Okay, so 90% of hydrogen produced in industry is used for synthetic application. Okay, 90% of hydrogen produced in industry. Okay, industrial production of hydrogen, preparation of hydrogen, we studied in our previous classes. We studied about the industrial preparation of hydrogen and laboratory preparation. Okay, what is the purpose to prepare the hydrogen to manufacture the other synthetic reagents? Okay, one such a process, that is Haber process, which is used to synthesize the ammonia in large scale. Okay, ammonia in large scale by using the hydrogen. Okay, what is the purpose to prepare the ammonia? Ammonia, it is one of the chemical. It is used for the manufacture of chemicals such as nitric acid, fertilizer and explosive. Ammonia, it is one of the chemical. It is very important, very important to prepare the chemicals. What are the chemicals? Nitric acid, fertilizer and explosives. All other explosives, ammonia, it is the main chemical. Okay, so for the synthesis of ammonia, we have to use the hydrogen gas. Okay, hydrogen gas. We have to use the hydrogen gas to prepare the ammonia. What is the process here? Haber process. What is the name of process? Haber process. Understood? So what is the first point? What is the uses of hydrogen? What is the first point? It is used to synthesis of ammonia by Haber process. Okay, it is used to hydrogen, used to synthesis of ammonia in Haber process. Okay, synthesis of ammonia by Haber process. Okay, so first application, first use, hydrogen, it is used to synthesis of ammonia by Haber process. Okay, what is the purpose to prepare the ammonia? Because ammonia is used for the manufacture of chemicals such as nitric acid, fertilizer and explosives. Okay, for such purpose ammonia we have to prepare. For preparing ammonia we have to use the hydrogen. Okay, the process, this process name Haber process. Haber process. We have to prepare the ammonia by using the hydrogen and nitrogen. Combination of nitrogen and hydrogen, we can prepare ammonia. This process is known as Haber process. Okay, nitrogen. What is the formula for nitrogen? N2, nitrogen gas. It combines with the hydrogen. Hydrogen, what is the formula? Hydrogen H2, N2 plus H2 gives NH3. We get ammonia. What is the formula for ammonia? NH3. Remember, what is the formula for ammonia? NH3. Okay, this process is known as Haber process. What is the temperature here? 380 degree Celsius to 450 degree Celsius. Okay, and what is the pressure? 200 atmospheric pressure. We have to apply 200 atmospheric pressure and temperature 380 degree to 450 degree Celsius temperature. We are combining the nitrogen and hydrogen gas. We get the ammonia. Okay, here one of the catalyst we are using. What is the catalyst name? Iron. Fe. Fe used as the catalyst. What do you mean by catalyst? Catalyst means substance used to alter or used to change the speed of the reaction. Okay, maybe increase the speed, maybe decrease the speed. That is called a catalyst. Okay, so here to increase the speed of preparation of ammonia by Haber process, iron used as the catalyst. Okay, iron it is used to increase the rate of the preparation of ammonia. Okay, iron used to increase the rate means speed. Used to increase the speed of the formation of ammonia by Haber process. Okay, this arrow mark indicates it is irreversible. This reaction is irreversible. We can the nitrogen and hydrogen combined to form ammonia. We can converting ammonia to nitrogen and hydrogen gas. Okay, this indicates this symbol. This forward reaction, this is backward reaction. Okay, in forward reaction, nitrogen and hydrogen gas combine to form ammonia. In backward reaction, ammonia we can convert nitrogen and hydrogen gas. Understood? This is the Haber's process. We have to balance the equation here. Here nitrogen, two atoms nitrogen having, but here only one. So we have to make here 2. Now hydrogen, here 2 hydrogen atoms are having, but here 2 into 3. 2 3s are 6 hydrogen atoms having. So we have to make here 3. So 3 2s are 6. Understood? These are about the preparation of ammonia by Haber process. So hydrogen is main substance or main gas is to prepare the ammonia by Haber process. Okay, this is the first use. And what is the second use of hydrogen? It is used for manufacture of solvent like methanol. Okay, it is used to manufacture of solvent. There is example methanol. Okay, so hydrogen used to manufacture of the solvent. Which is solvent? Methanol. What do you mean by solvent? Solvent, it is used to dissolve the solute particle. Solvent we have to use to prepare to dissolve the solute. Okay, for example, water. I am telling one of the example for the solvent. For example, I am taking sodium chloride. Okay, sodium chloride when dissolved in water, we get the salty solution. Here sodium chloride salt we call as the solute, and water it is the solvent. Okay, solvent is one of the substance used to dissolve the solute particle. Okay, so here the hydrogen used to manufacture the solvent. Okay, like methanol. How we can prepare? How will you prepare the methanol? We have to combine carbon monoxide with hydrogen. Using copper as catalyst, we get methanol. Carbon monoxide with hydrogen, copper is just the catalyst. Here we get the methanol. Okay, so carbon monoxide, what is the formula for carbon monoxide? CO, carbon monoxide plus hydrogen, H2, hydrogen. So here, what is the catalyst we are using here? Copper, Cu. We get methanol. What is the formula for methanol? CH3, that is methyl. OH means all. Methanol. Understood? So carbon monoxide, this is the carbon monoxide. It combines with hydrogen. The copper acts as the catalyst. Here we get methanol. Understood? Okay, so what do you mean by catalyst? Catalyst means the substance used to alter or used to change the speed of the reaction without involving any chemical reaction. Okay, it does not involve any chemical reaction, but it can change the speed, change the rate of the reaction. Okay, so the hydrogen, what is the second use? It is used to manufacture the solvent like methanol. Okay, so CO, carbon monoxide, when combined with hydrogen in the presence of copper as catalyst, we get methanol, CH3OH, methanol, CH3OH. Here we have to balance the equation. Here carbon 1, here also 1 carbon. Oxygen, here 1 oxygen, here also 1 oxygen. Hydrogen, here 2 hydrogens, but here 3 plus 1, 4 hydrogen having here. So we have to make here 2. Equation is balanced. 2 2s are 4. Here also 4 hydrogen. Understood? This is the second use of hydrogen. And what is the third use of hydrogen? What is the third use? It is used to, hydrogen used to convert unsaturated fatty oil to saturated fats. Okay, unsaturated fatty oil to saturated fats. That is vanaspati. Okay, unsaturated fatty oil. Unsaturated fatty oil to saturated fats, that is vanaspati. So hydrogen, what is the third use? Hydrogen used to we can prepare the vanaspati, one of the oil. Okay, so unsaturated hydrogen, we can convert unsaturated compound to saturated compound. Okay, already last class we studied about that. Hydrogen, we are using hydrogen as a reducing agent. Hydrogen as a reducing agent, we can convert the unsaturated compound to saturated compound. What do you mean by unsaturated? Unsaturated mean in a compound having double or triple bond, multiple bond, that is unsaturated compound. Saturated means single bond. Okay, single bond. Understood? Here, what is the reducing agent? We are using platinum and hydrogen. Platinum with hydrogen we have to use here as the reducing agent to prepare vanaspati. Okay, vanaspati, that is saturated fats. Okay, understood? This is the third use of hydrogen. What is the fourth use? What is the fourth use of hydrogen? Hydrogen, it is used in metallurgy. What is the fourth use? We can use in metallurgy. Hydrogen we can use in metallurgy to reduce metal oxide to metals. Okay, used in metallurgy to reduce metal oxide to metals. Metallurgy. Okay, metallurgy means what do you mean metallurgy? Metallurgy means when we have to separate the metals from each ore. Okay, how we get the metal from each ore. Okay, for example, what is the ore of tungsten? Tungsten, one of the metal. What is the ore of tungsten? Wolframite. Okay, so wolframite is the ore of tungsten. So we have to separate the tungsten from wolframite. Okay, this is the ore. So another one example, we have to extract the aluminium from aluminium oxide. Aluminium oxide is the ore. We are getting the aluminium from our earth crust. We get its ore. Okay, so we have to separate the metal from its ore. Okay, so this is called a metallurgy. So in metallurgy, so hydrogen we can use in metallurgy to reduce metal oxide to metal. So hydrogen, what is the important property? Reducing property. Okay, hydrogen, one of the important property having, that is the reducing property. So using hydrogen, we have to reduce metal oxide to metal. Okay, for example, copper oxide, CuO, copper oxide, CuO plus hydrogen, H2, we get copper. Okay, copper plus H2O. This oxygen combines with this hydrogen to form water, H2O. We can get copper. Metal. Okay, so hydrogen used to convert the metal oxide to metal. Another one example, tungsten oxide. W means tungsten. Tungsten, what is the symbol for tungsten? W. Okay. O3, tungsten oxide plus hydrogen. Hydrogen, it is one of the reducing agent. So we have to we can reduce the metal oxide to metal. So tungsten oxide plus hydrogen, we get this oxygen combines with the hydrogen to form water. So we can separate the tungsten from the tungsten oxide plus water. Understood? So we have to balance this equation here. These two equation we have to balance. The first equation, here copper, only one copper, here also only one copper. Oxygen, here one, here also one oxygen, and hydrogen here two, here also two hydrogen. So equation is balanced. Okay, but here the tungsten, here also one tungsten, hydrogen here, oxygen here three oxygen, but here only one oxygen. So we have to make here three oxygen. Then we have to balance the hydrogen. Here hydrogen, only two hydrogen having, but here 3 twos are 3 into 2, 3 twos are 6 hydrogen atom having. So we have to make here 3 twos are 6. Equation is balanced now. Okay, understood? These are about the uses of fourth use of hydrogen. What is the fifth use? What is the fifth use of hydrogen? It is used to cutting and welding of metals. What is the fifth use? It is used to hydrogen. We can use to do cutting and welding of metal. Cutting, you know about the cutting means cut. Okay, we can cut the metals. Metal means very hard material. So using hydrogen, we can cut the metals. Okay, by firing. Okay, hydrogen, we know hydrogen, we studied about that hydrogen when combines with the oxygen to form water. This is one of the explosive reaction. Okay, explosive, we get a lot of energy from this reaction. Okay, understood? So from this we have to we can prepare, we can cut the metals and we can welding the metals. Okay, using atomic hydrogen and oxyhydrogen. Atomic hydrogen means hydrogen, H. Okay, H, and oxyhydrogen, HO. Oxyhydrogen. Okay, now these two atoms, it is not in combined state, it is in separate state. Oxyhydrogen and atomic hydrogen, we can using the oxyhydrogen torches. Okay, atomic hydrogen, oxyhydrogen torch means it give the light. Okay, light, it give the fire. Okay, using the atomic hydrogen and oxyhydrogen torches, we are used for cutting and welding of metals. Okay, understood? So this is the fifth point, the fifth uses of hydrogen. What is the sixth use? What is the sixth use of hydrogen? When a liquid hydrogen used as a rocket fuel. Liquid hydrogen used as a rocket fuel. Liquid hydrogen used as a rocket fuel. Okay, liquid hydrogen used as a rocket fuel. Understood? So liquid hydrogen means when hydrogen gas, when we are applying high pressure at the room temperature, we are applying high pressure, we can get the liquid hydrogen. This liquid hydrogen used as the fuel for the rocket propellant. We are using hydrogen. Okay, this is the sixth use of hydrogen. What is the seventh use? Hydrogen, it is used to fuel cell. Okay, hydrogen is used in fuel cell to generate electricity. We studied about that in last class. We studied about that when hydrogen combines with oxygen to form water. Okay, this reaction is the very explosive reaction. Okay, this from this reaction we can get the lot of energy. So we can use this two, hydrogen and oxygen, in one of the cell, that is fuel cell, hydrogen oxygen fuel cell. Okay, by using the hydrogen and oxygen fuel cell, we can generate the electricity. We can generate the electricity. Understood? These are about the uses of hydrogen. Okay, what are the uses of hydrogen? First one, used for the synthesis of ammonia by Haber's process. This ammonia we can use to prepare the nitric acid and fertilizers. Okay, and the second use, it is used for the preparing the solvent. This is to prepare the solvent by using copper as catalyst and carbon monoxide and hydrogen and copper as catalyst here. What is the third it is used to manufacture the unsaturated fatty acid to saturated. It is used to convert the unsaturated fatty acid to saturated fatty acid. Okay, and what is the fourth use? It is used in metallurgy to reduce metal oxide to metal. Okay, it is used to metallurgy. Used in metallurgy to reduce metal oxide to metal. What is the fifth use? It is used to do cutting and welding of metal. Hydrogen, atomic hydrogen and oxyhydrogen torches are used to cutting and welding of metals. What is the sixth use? Liquid hydrogen used as the rocket fuel. Liquid hydrogen is used as the rocket fuel. Okay, what is the seventh use? So hydrogen is used in fuel cell to generate the electricity. Hydrogen is used in fuel cell to generate the electricity. These are about the uses of hydrogen. Very, very important. Very, very important. Okay, study well. And then next topic, compounds of hydrogen. Compounds of hydrogen. Okay, compounds of hydrogen. One of the compound of hydrogen, what is the compounds of hydrogen? Okay, carbohydrate, methane, CH4 methane, carbohydrate, glucose, C6H12O6, fructose, and the sucrose, H211. Okay, these all about the compounds of hydrogen. But today in our topic, the water. Okay, water, it is one of the compound of hydrogen. Okay, water, what is the how we can tell about this is compound of hydrogen means H2O. When two hydrogen atoms and one oxygen atom combine to form a water. Okay, everyone know about the water. Water is one of the most abundant and important substance known to man. Okay, it is present in the air as water vapor, and in the ground in the form of underground streams. Surface water in the form of oceans, rivers and lakes covers about 3/4 of the earth crust. Okay, it is essential. It is an essential constituent of all animal and vegetable matter. We know about the water. In our earth surface contains approximately, okay, in our earth surface contain approximately 70% of ocean. 70% of ocean, which is the major source of water. Ocean is the major source of water. 70% of earth covered by the ocean. However, seawater contains many dissolved salt. Okay, seawater we cannot use in our drinking purpose because the seawater contains many dissolved salts. Okay, so hence it cannot be used directly. We can purify this seawater to drinking water. We can purify, okay, by many process. Okay, and water is essential for our living things, and our body contains 65% of water. In our body contains 65% of water. Okay, how the 65% water in our blood. Okay, blood and other things made by water. Okay, understood. These are about the water. What is the structure of water? Structure of water means H2O. Okay, two hydrogen combines with one oxygen. This is the structure of water. The bond angle between these two hydrogen and oxygen, two hydrogen atoms, the bond angle is 104.5 degree. 104.5 degree bond angle between the two hydrogen atoms, 104.5 degree. Okay, this is the comes the hydrogen, introduction about the hydrogen. We studied about the hydrogen having two forms, two isomeric forms, that is orthohydrogen and parahydrogen. We studied in our previous classes. Like that, water can also form two forms, okay, two isomeric forms, that is ortho water and para water. Ortho water and para water. Okay, ortho to para ratio. Okay, ortho water and para water. It is depending upon the hydrogen. Okay, it is depending. We know about that. Ortho means the nucleus. Okay, nucleus of an atom can spin in same direction, means ortho form. The nucleus of an atom can spin in different direction, means para form. Okay, we studied in our hydrogen has orthoform and paraform. Okay, hydrogen atomic number 1, mass number 1, so number of proton 1, so in the nucleus having the protons. This proton can spinning its own axis, okay, by spinning in same direction, clockwise direction means orthoform. Spinning and different opposite direction, that is called the anti-parallel direction, that is called the parahydrogen. Like that, here water also, when oxygen combines with two hydrogen atoms, these two hydrogen atoms can form ortho and para. Okay, one hydrogen atom can spinning in same direction. Two hydrogen atom, orthoform means two hydrogen atoms spinning in same direction. Paraform means two hydrogen atoms spinning in opposite direction, that is called para water. Okay, ortho water and para water. These are about the introduction about the water. What are the physical properties of water? What are the physical properties? We know water is a colorless and volatile liquid. Water is a colorless and volatile liquid. Okay, the one of the important property means that is the intermolecular hydrogen bonding. The water can form intermolecular hydrogen bonding between the water molecule. Okay, water means, for example, one of the water hydrogen, intermolecular hydrogen bonding means this is one of the water hydrogen combines with the oxygen, and this oxygen can bonding with another one water molecule. This is called the intermolecular hydrogen bonding. This oxygen can form another one, can bond formed between another one water molecule. Okay, another one water molecule. This hydrogen and bonding with another one oxygen in water molecule. Okay, this is the intermolecular hydrogen bonding. So inter means between. The water molecule can form bond between the different water molecules. Okay, can bonding. This is called intermolecular hydrogen bonding. Very, very important property. And another one property, the hydrogen bonding is responsible for high melting and boiling points of water. Okay, boiling point of water means, what is the boiling point of water? 100 degrees Celsius. Okay, 100 degrees Celsius. Why it is very high boiling point? Because of the hydrogen bonding. Okay, it need high energy to dissociate these bonds. Okay, this bond, break this bond. So the melting and boiling point is high here. Understood? In our textbook, one of the table number 4.2 in 107, page number 107, table number 4.2, the properties of water. Okay, what are the types of water having? There are three isotopic form of water having. What are the protium water, deuterium water, and tritium water? Okay, there is called H2O. H2O means normal water, protium water. D2O means heavy water. T2O means super heavy water. Okay, H2O protium, deuterium heavy water, and T2O super heavy water. Okay, in our Earth's atmosphere, large amount of water is ordinary water. That means protium water. Deuterium water is the some water. Okay. Small amount of water having the in our Earth's atmosphere in the form of deuterium water, but tritium water, it is super heavy water. It is very high heavy water. So here this tritium water, it is a small amount, a trace amount of tritium water is present in our Earth's atmosphere. By means 10 power 18 10 power 18 water molecule contain 1 molecule of tritium water. Okay, 10 power 18 ordinary water contain 1 molecule of tritium water, T2O. Understood? So, and here some of the properties are having. Okay, if you have interest, you can read these properties. Okay. Today's your assignment. One assignment, write the uses of hydrogen. Students should study and write and send me through my WhatsApp number. Okay, if you have book, take your book now. Take page number 105. The last paragraph. What are the uses of hydrogen? Over 90% of hydrogen produced in industries is used for synthetic applications. One such process is Haber process, which is used to synthesize ammonia in large scales. Ammonia is used for the manufacture of chemicals such as nitric acid, fertilizers, and explosives. Okay, what is the equation here? Nitrogen N2 plus 3H2 gives 2NH3. Okay, by manufacturing ammonia, we can use the hydrogen and nitrogen. By combine these two, nitrogen and hydrogen, we get the ammonia. This process is known as Haber process. What is the temperature we are using here? 380 to 450 degrees Celsius. What is the pressure? 200 atmospheric pressure. Okay. Which catalyst we are using for synthesis of ammonia by Haber process? Iron. Fe. Iron is used as the catalyst here. Okay. Second point, it can be used to manufacture the industrial solvent methanol from carbon monoxide using copper as catalyst. Here carbon monoxide, CO, carbon monoxide plus hydrogen. We are using here copper as catalyst. We get the methanol. What is the formula? CH3OH. Okay. What is the third point? Unsaturated fatty oils can be converted into saturated fats called vanaspati by the reduction reaction with PT bar H2, platinum with hydrogen. Okay, what is the fourth one? In metallurgy, hydrogen can be used to reduce many metal oxides to metals at high temperature. Okay, for example, CuO, copper oxide plus H2 gives copper plus H2O. Okay, tungsten oxide, WO3 plus 3H2 gives tungsten, W plus 3H2O. Understood? And what is the fifth point? Atomic hydrogen and oxyhydrogen torches are used for cutting and welding. What is the sixth point? Liquid hydrogen used as the rocket fuel. Okay. What is the seventh point? Hydrogen is also used in fuel cell for generating electricity. Up to here, you have to mark. Thank you all of you. Thank you.